All right, let's dive in. Today, we're going to completely change how you approach coding. We are leaving the world of repetitive, boring tasks behind and jumping straight into writing smart, elegant solutions. And this isn't just about saving a few minutes here and there. This is about building code that's actually easier to read, to fix, and to grow into something huge.
Okay, be honest. How many times have you done this? You write a couple of lines of code, then a little later you need those exact same lines again. So what do? You copy, you paste. And then maybe you do it a third time. Yeah, it works, but let's be real. It's clunky, and it makes your code a total mess to deal with later.
So if you're sick of all that copy-pasting, good, because there is a much better way. We're going to talk about creating building blocks. These little packages of code that you write one time, and then you can use them over and over and over again wherever you want.
And our first and honestly most important building block is the function. The best way to think about a function is like a recipe. You write down all the steps just once. You give that recipe a name, and then whenever you want to make that dish, you just say, hey, make the recipe. You don't have to write out all the steps every single time.
So what exactly is a function? Well, it's basically a named chunk of code that's all bundled up to do one specific thing. The code inside of it, it doesn't do anything at first. It just sits there patiently waiting until you call it by name.
And you know what? Making one is super simple. It's just 3 steps. First, you define it with the keyword def, give it a name, and add some parentheses. Second, you just indent your code right underneath it. And third, whenever you're ready to run that code, you just type its name with the parentheses. That's it. You've officially made your code reusable.
Okay, so we've got our basic recipe. But what if we want to switch up the ingredients? What if one day you want a chocolate cake and the next day you want a vanilla one? This is where functions go from being useful to being incredibly powerful.
Check this out. On the left, we've got a static function. It prints hello every single time. Kind of boring. But look at the right, a dynamic one. By adding name inside those parentheses, we've created a little slot, a placeholder that lets us pass in different information each time. Now we can say hello to anyone.
Now, this brings up 2 key terms you're going to hear all the time. That placeholder you create inside the function, like name in our last example, that's called a parameter. The actual data you send it when you call it, that's the argument. So think of it this way. The parameter is the parking spot, and the argument is the car you actually park in it. Functions don't just have to do things. They can also give you something back. After a function finishes all its work, it can send a result back to your main program. And it does this using the return keyword. This is so useful for getting answers out of your code.
Here's a perfect example. Imagine you're making a quiz game. You can have a function that checks a player's answer. If they get it right, it returns a 1. If they get it wrong, it returns a 0. Then your main program can just add up all those 1s and 0s to get the final score. Simple, right?
Okay, so we can build our own tools with functions, which is awesome. But why reinvent the wheel? What about using tools that other brilliant people have already built and perfected? Well, that brings us to our next building block, modules. This is all about working smarter, not harder.
So a module is really just a file full of Python code, usually a whole collection of helpful functions. And to unlock all that power, all you have to do is write one simple line, import, and then the name of the module. It's like checking a book full of solutions out of a library.
And Python comes with a massive library of these toolboxes right out of the gate. The random module is your best friend for making games. It can pick a random card, roll dice, whatever you need. The OS module lets your code talk to the computer's operating system to do things like check if a file is there. And the math module, it gives you superpowers for all sorts of advanced calculations.
So we can build our own functions, and we can borrow from modules. Now for the last piece of the puzzle, putting some armor on our code. Because, let's face it, in the real world, things go wrong. Users type in weird stuff, files disappear, and our programs need to handle that without just crashing and burning.
The technical term for when something goes wrong is an exception. It's basically an event that just stops your program dead in its tracks. And if you don't have a plan to handle it, that interruption means a full-blown crash and a really unhappy user.
Just look at this comparison. On the left, our code asks for a number. The user types pizza, and boom, it crashes with a value error. Game over. But on the right, we've wrapped that same risky code in what's called a try-except block. The program tries to run the code, it sees the error, catches it, and instead of crashing, it runs our backup plan. In this case, printing a helpful message. So much better.
So let's just take a quick step back and look at the awesome toolkit we've just put together. These are really the fundamental tools for writing code that is clean, efficient, and tough enough to handle anything.
So, to recap, you use def to create your very own reusable functions. You use parameters to make those functions flexible. You use return to get answers back from them. You use import to borrow powerful code from others. And you wrap your risky code in try and accept blocks to make sure it never ever crashes unexpectedly.
By getting these 5 concepts down, you've seriously leveled up as a programmer. You're not just writing lines of code anymore, you're engineering systems. Your code is smarter, it's cleaner, and it's way more robust. So really, the only question left is, what are you going to build first?